So we will talk about electric dipole today. So let us consider two charges which are separated by some distance d. So let us consider some charge, two charges. So let me first draw the coordinates x, y and z. Okay, now consider two charges. Let's say this is plus q and another charge which is separated by a distance. This is minus q, okay, along minus z axis. So we have two charges. Now consider a point p which is far away from the dipole. So you can see the center of the dipole is at origin. So here is the center. So you can see that the center of this dipole is at origin. Okay, so we will see later on, we will see what is the situation, what will be the situation if it is not at the origin, and how we can extend the current results for such cases. Now let us consider that this distance, that means these charges are separated by some distance, that is plus q and minus q. Each charge is having same magnitude but of opposite polarity. So the distance is d. Okay, now let us consider the point P, which is very much far away from the dipole, and the dipole means actually the center of the dipole is origin, okay, that I have already mentioned. So let us consider the distance from the charge q plus q is this much. Let's say the distance is r1, and the distance from the charge minus q to the point P, the distance from the charge minus q to the point P is r2, and the distance from the origin, or distance from the center of this dipole, or we can say it is distance from the dipole. So in general, when we consider this dipole, its location is nothing but its center. Okay, so it is given as r. Now you know that the voltage due to plus q, at the point P, is given as plus q divided by 4 pi epsilon 0 over r1. Okay, similarly the voltage at the point voltage due to minus q at the point P is given as minus q over 4 pi epsilon 0 into r2. Now what will be the total voltage? So the voltage at the point P, the voltage at point P is the voltage due to plus q plus the voltage due to minus q. So I will take the next page. So the voltage will be equal to q by 4 pi epsilon 0, okay, divided by r1 plus then minus q over 4 pi epsilon 0 into r2, or I can say my voltage is q by 4 pi epsilon 0 into 1 over r1 minus 1 over r2. This is equal to q over 4 pi epsilon 0, okay, 4 pi epsilon 0 into r2 minus r1 over r1 r2. Okay, now suppose the distance, you see this distance, suppose this distance is very much less than that of the r. R means it is the distance from the dipole to the point P. So if this is very much less than that of the r, that means the point P is far away when compared to the distance between the charges. We can say that the difference between r1, you can say that this r1 is approximately equal to r2, but anyway it is not equal. So let us consider what is the difference, r2 minus r1. So this will be approximately, you can say that it is r2 minus r1. if P is very far away from the center of the dipole. So what is this R2 minus R1? Okay, so let us consider this angle is theta. Okay, so in such cases you can say this angle is theta approximately, which is equal to this angle is also equal to theta. Okay, so since this, so if I take the cosine of this theta, so cosine of theta will be equal to the adjacent side. You see this is the adjacent side, so adjacent side is like R2 minus R1 divided by, okay, the hypotenuse is D, okay, D, or we can say that R2 minus R1 is approximately equal to D cosine theta, okay, D cosine theta. So we will replace R2 minus R1 in the above equation by using this. Now R1, I told you R1 is approximately equal to R2, so we have R1 R2 is approximately equal to each R, if the distance, this point P is very far away from the origin of the dipole, then R1 is approximately equal to R2, which is approximately equal to R. Okay, what is R? R is the distance from the origin. So we will say all these distances are approximately equal from the dipole. So we are actually observing from a point which is very far away from the origin of the dipole. So we will say R1 R2 is equal to R square. Okay, it's approximately equal to R square. So we will get the equation for the voltage as Q by 4 pi epsilon 0 into D cosine theta. Why D cosine theta? R2 minus R1 is D cosine theta divided by R square. Okay, R square. Now this distance D is actually, it is nothing but is the projection of D in the direction of R, or I can say, suppose this is my D and this is my R and this is my theta. Actually you see here, suppose I know this theta, then I can say my direction of R is AR, and let's say my D is a vector. Let's say my D is a vector. If my D is a vector which is pointing from minus Q to plus Q, so this is my direction of D. So here I am just considering only the magnitude of this vector D bar. Okay, so D is the magnitude of vector D bar. So I can say my D cosine theta is equal to my D which is projected in the direction of AR. So it is nothing but D dot AR, right? So D dot AR. So what do you mean by our D in our case? You see, I have considered the Z direction. So my D bar is nothing but the magnitude into the direction is AZ. So this is my direction actually. You can say this is my direction of D bar. So this is a vector. In the textbook actually they have used the bold face for representing the vector. Anyway, I am using D bar. Now you can say this is the magnitude. Okay, it's the magnitude. Now we will see with this notion we can say we can have this D cosine theta as D dot AR. Okay, D dot AR. So I can say my voltage V is equal to Q by 4 pi epsilon 0, okay, epsilon 0 into R square into D cosine theta. I can represent it as Q by 4 pi epsilon 0 into R square into D cosine theta will become the vector D bar dot AR. Now you see something as charge into some distance vector. So this is charge into distance vector. You can say that it is charge multiplied with distance vector. Okay, so that means this is equal to q into d bar. We will call this as the dipole moment. Okay, dipole moment. So it is a moment. Actually, you see here it is depending upon the charge. It's like it is depending upon the charge. If charge is more, you have more dipole moment. If the distance is more, you have more dipole moment. So we will have V is equal to the charge into distance. It is nothing but the dipole moment. We will call this as the vector p bar or p. Anyway, this p is a vector. Okay, so don't forget about this. It is a vector. Okay, so be careful. So p dot, we have ar, which is the direction vector of r, divided by 4 pi epsilon 0 into r square. Okay, so this is the equation. Now we will see how we can generalize this. This is z, this is x, and this is y axis, and as I told, this is plus q and another charge minus q, and this is my r. So let us consider my vector r. It is a vector r. I am showing in bold face anyway. It's a vector r, and this is the magnitude of this vector r. Vector r. Now you see, how can I represent my ar? I can represent my ar is equal to the vector r divided by the magnitude of vector r. So please note that this is a vector. Okay, here also is this is a vector. Okay, I am taking the magnitude. So I can get my equation as p, this is a vector, dot ar is nothing but is the vector r divided by 4 pi epsilon 0. This is actually the magnitude of the vector r. Okay, the magnitude of the vector r. So I have already the magnitude of vector r here, so it will be nothing but the magnitude of vector r, magnitude of vector r, magnitude of vector r, the whole cube, because there was already r square. Now one more r will come, so it become r cube. So this is the equation for the voltage. So but in this case I have considered my center for the dipole is at origin. Origin means it is the zero vector. Okay, now suppose I have another situation. If I have another situation, my dipole is not located at the origin. So this is y, x and z. Suppose my dipole is located here, somewhere here, and this is at the point at the center of this dipole. It is suppose r dash, and I am considering my point here. Let's say the position vector of this point is r. Then the vector which is joining here, it will be nothing but the vector which is joining here. It is nothing but, you see like this, the vector is nothing but the vector r minus r dash. Right? So my equation will be V is equal to P is a vector dot r minus r dash, all these are vector, okay, divided by 4 pi epsilon 0 into r minus r dash, magnitude the whole cube. Okay, so this is the general equation. So I hope it is clear to you.